Hello and welcome to, not GeeCON, because you're already here since yesterday, my presentation called Simple Modern Java Microservices in the Cloud. One thing I can promise you, those are not the facts you expect to see, or some of you will be surprised after you have listened to all of what I have to say. If you're a bit sleepy, if you've had a good lunch, if you've maybe been fast enough to get to what one of the sponsors was offering, because I wasn't, then the TLDR version of the talk is building a lot of services is complex, and that's normal and that's okay. So limit the accidental, unnecessary complexity, limit the number of moving parts, focus on the business side of things, because technology, while very exciting, and this is why we are all here, is actually not going to give you that much of an advantage in most cases. Now, my name is Andrzej Grzesik. Very easy to say for those of you who know how to say it. If not, you can call me Ax, and that's what everybody calls me. This is also my email is ax@revolut.com. If you want the slides, drop me an email. You'll get them quickly. If you are going to wait for the conference to publish the slides, you're going to wait some amount of time because they should also get there as well. And a couple of facts about me. I'm very proud to be a Java champion, Java 1 rockstar, have been involved with the Polish Java user group, this conference, and some other places. If you have any questions about the talk, just ask. That means you can wave your hand, and I'll probably not see it, but you can scream, and then somebody might actually come to you with a microphone, or you can use the awesome app called Slido and do things there. If you have questions about Revolut, where I work, talk to me after, or visit the Revolut crowd at the stands, which they have. And obviously, as most of the tech companies out there, we are hiring. So, yeah, my opinions presented in this talk and elsewhere are my own, so nothing official. And I like dry jokes. Some of you will have to bear with that, but that's also a sign for me to drink water because, yeah. Going forward, modern Java microservices in the cloud. Some of you could say bingo right now. But what makes a service modern is the core question here. Is it going to be the language? So do I have to use a specific one to call it modern? Is it the technology? Is it being in the cloud? Does that make us modern? Well, probably not, since 10 plus years ago. Is it the frameworks that we use or the versions of the frameworks that we use? Again, probably not. Is it the architecture? Do we have to be CQRS event source, or can we do triple tier, or maybe we should do something else and call it modern? I'll leave those questions open for now. Now, let's think about software without the bloat. Can you imagine, well, you probably here work with software, so can you imagine the software that you work with, but without whatever parts you feel that are bloated, that are not nice to work with? Maybe it takes forever to deploy. Maybe it takes 2 days to get a green build and to actually merge. Well, do you believe that code quality actually matters to how quickly you are able to get stuff done? That's a rhetoric question, but the answer is most likely yes. But now, can you imagine what would it be like if you could always, or almost always, write the best code possible and do things as quickly as possible? That's so nice and also so unreal that it also feels like a dream that's never going to come true, unless you're sleeping, because then everything is possible. And then we get into a problem. Everyone's answer about how we can get to such a state is going to differ. And be my guest, try at the party to convince the other person that you're speaking to about how you would do this, and they can do the same to you. And if we at the end all agree and converge and not end up in a tabs versus spaces kind of fight, it will be awesome. But what is bloat? And I warned you. So, is it the language? Which language should we use to avoid having bloat in our code? I've seen research which tried to compare the number of defects depending on the language used to deliver a project, and sadly there were no significant differences. Fans of Kotlin, Martin included, will say Kotlin of course is the best. Fans of Scala will say obviously Scala is the best. Fans of Scala 2 will say no, Scala 3 is not that the bestest, it's Scala 2 which is the one. I like Java, I like Scala, I use both. The language sadly is not the one thing that makes that such a big of a difference. But in choosing the language and the technologies, I like to use what I call the 2 a.m. check. And it goes like this. Imagine you've been out, perhaps on a conference party or somewhere else. You've had a good evening, and then support calls. They need help. And you need to read whatever is in there, and you need to reason about it. And which language actually passes the bar? In my opinion, for example, the negative example of this was the old style Scala Z, because it was kind of squiggly lines. But what we use in Revolut, the place I work in, is primarily Java, and we have tons of Java, and it's very simple Java because it's very readable and it's explicit. So you read, and what you read is what gets executed. We also use Scala and written in the same style, but we use much, much less of it. Could it be the framework that makes the difference? Well, we've been doing Java for many, many years. Frameworks change, and today's forecast of which framework you should use, probably Quarkus, probably Micronaut, probably something else. Bottom line, it differs. Bottom line, there is no single answer. So probably that's not the differentiator. Is it the database? Well, 20 years ago, we all had to migrate to NoSQL. 10 years ago, it was not only SQL, then back to SQL. Now it seems that a lot of people are using Postgres and some other things, and it is not really one answer that makes all the difference. So maybe it is the architecture. But you get where I'm going. It's not one solution that always guarantees success. Is it the tests? Well, the only thing I can say about the tests is everybody wishes they wrote more, and that's what we do. We write a lot of them, and they certainly help, but you probably have worked with tests that cause you trouble, that make it more difficult to evolve the software. But then let's try one more time. The most modern set of technologies, a few years ago, you could imagine, you go Kafka, you go Kotlin, and you go Kubernetes. Are you going to be successful? Some of you are using this and are successful, but I've heard this awesome term called 3K apocalypse, referring to exactly this set of technologies. This is not to say I dislike them or anything. As in, we use Kotlin and we use Kubernetes in Revolut, and we're very happy because of that. So it's not that they are wrong or right. It's just they do not guarantee success or lack of it. Bottom line, number one. Anybody dares to shout an answer? Yes, dog excrement storm, for example. Good answer. So, what makes a service modern might not be exactly the question that we should be asking. Maybe we could challenge this and ask it differently. So, is there anything wrong with legacy? Or maybe we're barking at the wrong tree, to refer to some religious leaders from recent news. There is a term in biology called calcification. I will let you read the definition while I'll drink some water. Too long didn't read version is calcium accumulates in the body cannot move as much as it used to be able to. Going back in time, using this awesome vehicle, accelerated to a very precise speed, gives you, well, if you go far enough, you get the Big Bang, or not, but that's too far. Year 1997, according to Wikipedia, which turns out to be wrong because it's not exactly that year and how it happened, but EJBs. Who here has worked with enterprise Java beans? Wow, I see 1/5 of the room, kinda. Some of those hands are really scarred, also for a reason. It might be IBM's fault, it might not be IBM's fault. I don't know the history. I haven't been there at the time doing EJBs. This is what's written in the Wikipedia page, and this is why I say it's IBM's fault. What happened after is we got the serverless specification version 2.2, the one we love, which enabled web applications to enter the Java platform. And then came year 2001. Good, you've recognized this, which gave us EJB 2.0. And EJB 2.0 was much better, at least twice better than EJB 1.0, because they were faster, because you could do local calls, and all EJBs before could only do remote calls, even if that was on the same machine. And they were also terrible because they were using something called xdoclet. If you know what I mean, you know the pain. If you don't know what I mean, do something better, go out for a walk, don't research it. It was terrible. Year 2003, we get Spring version 0.9. Some people could say it should be Spring 0.5 or maybe 0.7 with a percentage, but it doesn't matter. We got Spring because EJB was too complex. And so we move on. 2005, we get Ajax, which according to me stands for asynchronous JavaScript and JSON, because who here in this room sends XML over Ajax? Anybody? I see no hands. QED. Then we get EJB 3.0. EJB 3.0 is much easier and much simpler because, you guessed it, EJBs were too complex. And so enter year 2014. We get the awesome, the amazing, the simplified, and with new visuals, Spring Boot. Spring Boot happened because Spring was too complex. Let's roll forward, and this is from a video, I think from Confitura. It says, actually, have my attempt at being an English translator, that Java EE had a small, well-thought API 10 times smaller than Spring. Did we make a circle? 2016, we get microprofile. So let's get back to the original question. What makes a service modern? The trend that we keep getting, the modern aspect, is simplicity. We like getting to simpler, simpler, simpler. We simplify and we take the exciting out of certain aspects of doing software. This keeps happening, and this keeps happening across all the components in the software that we're dealing with. Starting with the stack. If you remember old days of making web applications in Java, it used to be quite complex. Now we get a hello web world which could be very, very simple. For example, like this. Maybe not exactly a one-liner, but I think 2 or 3 lines is decent enough. Spark Java, Helidon, Javelin, you can probably get a similar result with a different framework. Again, which one you pick doesn't matter, and they are all good. So let's have a look at this graph. What does it tell us? It tells us that Helidon has had activity during this amount of time, and there is this amount of activity, this amount of commits. We can have a look at the same thing for Spark, less activity, and then you can compare it with Javelin. What is the conclusion to be drawn out of this? Well, for us, the conclusion is because Spark Java does not see a lot of development and we use it, as in it is our default REST endpoint framework, we probably will move out of Spark Java into something else. But as a default, in terms of features, it gives us everything we need. And if you ask me, I will say, as of today, my personal favorite is Helidon, but I haven't tried all of them. And there was an awesome presentation about Quarkus today in here, and there are other awesome presentations about other options available. So let's go back to the question, how do we keep our services modern? My theory is by preventing calcification. Okay, calcification, modern, how do we keep it? So if we want to prevent it, we have to think about how does it happen. Well, the answer to how does complexity happen in any software project is one commit at a time. It can be a mega commit or it can be a small one. Because I have not met anybody who approached building software with, let's build legacy. I have heard approaches of people saying, yeah, let's do whatever, or let's do the whatever. And that was actually heard in California in a very specific technical company, which you would never expect to approach things like that, but that happened. And I could add an asterisk. There was, I think, one contest, and I will again say in Confitura, which with the goal of let's build the most legacy software that you can, but that's an extreme thing. We don't do it like that. We never expect to build legacy. Or I have not met people who want to build legacy. Maybe there are companies who actually do. So, frameworks. Once upon a time, in the Java world, when you had a problem to solve, people would say, let's use Spring and Hibernate. And that's probably okay if your project or problem requires Spring and Hibernate. The problem I had with that attitude, because that was around 2009, maybe 8, maybe 10, doesn't matter exactly. Spring and Hibernate were the default answers to the questions not even asked yet. What is the project going to do? Where is it going to be deployed? What is the complexity? What is the goal? Everything. Now, spring and hibernate, and then we start asking questions. Feels a bit backwards. This test, you already know, but you can also apply it to frameworks. Because there are two kinds of engineers. Those who have, and those who haven't fixed things late at night that have debugged crazy stack traces because of the extra unnecessary complexity in the software. What is the conclusion? The one I like, and the one I keep making, is code being run should be visible. And it also ideally should be tested. Which means, in turn, no magic frameworks. No magic frameworks means frameworks like this. Drop Wizard, because it's simple. Finagle, because it is simple. Java and Helidon, Spark Javas. And this list is not complete, it's not exhaustive, it's probably slightly incorrect even if you look into it. But the bottom line, again, is this. Apage unnecessary complexity. Begone unnecessary complexity. But I've told you I work at Revolut, so the question is, how do we do it? What does a typical Revolut application look like? Are we doing what I say we are doing? And if you look onto this big screen, you can certainly see the font big enough. Sorry. This is what a random application I chose, what the startup code looks like. Do you think you understand what's happening in there? I hear somebody trolling, but I also see some heads nodding, and the heads nodding overrule you, so yeah. We try to make code explicit, and we try to make code simple. Because this means that if I need to go through it, the reasoning about it is going to be trivial, which means I win exactly 0 smartness points after going through that code base, maybe after debugging it. But that makes it much easier to go into quality, because if that's simple to reason. No unexpected things, which means no bugs. And of course, we write tests. Everybody writes tests, right? I'm not looking, so answer whatever you want to. You can be truthful. But why do we talk about tests? Because you should know what lifetime of a service you're building for. So if you're building a service that should be only alive for the next 5 minutes because I want to live code a demo on this conference, I'm probably not going to fully TDD it with and BDD it with all kinds of performance, black box security tests, because I have no time, I have something else to do. On the other hand, the services we are building in Revolut, and probably a lot of the business services you are building in your organizations, are optimized for longevity, because you expect the organization to stay around for a long while, and you probably expect that the code will be running for a long while. What that means is software with, as in you can read it yourself. The left part is where we, the software people, excited by maybe what we heard at a conference, will make a decision based on magic, fanciness of a framework, maybe doing less tests, but after we spend some time, we will have bloat, we will have more complexity, we will have already calcification present. Said differently, it is inefficient to build software that very shortly needs a rewrite. In most cases, unless you're experimenting or learning or something like that. But in the long run, if you want to build a service that solves a problem and it solves it, then why would you come back and to rewrite it? That's probably, yeah, as I said, it's inefficient. So what do? We do constructor-based injection. Is it radical? Maybe. But that gives us one specific thing. We can see in the IDE where the instances of the objects that we get come from. That means that if you have 17 argument constructor and you might need to make it into an 18 argument constructor, you feel that something is wrong. Maybe something is dying inside of you. And that is exactly the kind of feedback that you want your source to give you. If you have @inject absolutely everywhere, the framework, assuming you use one, is going to do exactly what you ask it to. If you want to insert a database connection into your web layer, be my guest, who cares? But if you have to do it through software, and there is no good way to do it, Sometimes it's for a reason. We also like immutability. And with immutability come the obvious benefits, as in concurrency is easier, reasoning about things is easier, but we go one step further. We go and expose the fields, but we also follow this gentleman's advice. And we will try to uphold invariance. So you will see fields, but you will see a lot of checks. And those checks happen absolutely everywhere through our code base. It's probably the most significant feature of Revolut's code base to me when I look at it, as in we have those checks almost everywhere. They might seem redundant. It would be a very good question, so let's pretend somebody has asked it. Very good question indeed. Is that not redundant? No, because those checks and validations and enforcements and stability sprinkly magic dust, because that's stability dust. It's tiny, but over time it gives you compound interest in stability, in reliability, in reasoning power about your software, because you can make assumptions because they have been enforced, and they have been enforced throughout the whole stack, throughout the whole call, through all the calls, through everywhere. And that is very, very nice. In the long run, that means that you can safely bet about what the software does. If, on the other hand, you wouldn't do it, your test could, for example, inject something that's completely incorrect, and the test passes, you have a test, and everybody's happy, and then reality comes, and maybe production support calls you. Also, coming soon to a Java 17 near you, you will have records, which means the left side can become the right one, and they are roughly equal if you look at the bytecode generated. And then somebody here could say, you should use Lombok. So, quiz for you. And I will wait a bit before we go forward, so have a look at it. When somebody knows the answer, raise your arm. We'll wait for at least 3 hands to materialize. I see nothing. So what are we looking at? Data. That's probably a data class. So probably everything is final. And probably I can just drop it in the hash map. Yes or no? There is one no. There is nothing else in the audience. QED. It's not obvious. The answer is, it might look like an immutable data class, but it's not, because it has a setter. And if you drop it into a hash map, and then you change the value, and the hash doesn't map anymore, you will not get it through get. I'm so sorry. It's not about bashing Lombok. There is nothing wrong with Lombok, because Lombok does exactly what Lombok advertises with regards to all those annotations and all the magic that it gives. The problem that I see with using Lombok in this fashion is it's not obvious about what is the effect of having code like this in your code base, unless you know Lombok very well. So, where do we keep mutability? What about mutability? Where should it live? Where is it okay to have mutability? Option 1 is keep it in the database. So the only mutability that happens, and this is kind of what our software does, is when we need to mutate data, we store the mutated data in a database. Another option is to use CQRS and use event sourcing. You've heard about it. There are presentations about it. I'm not even going to try to summarize what CQRS and event sourcing are. But why this? Because you take the moving parts to a small tunnel, and only their mutability happens. And then which database should you use? Well, it really doesn't matter that much. I would personally say please don't use Mongo, but that's just because I don't particularly enjoy it. We use Postgres almost everywhere, as 99% of our services do use Postgres. It has a very well understood consistency model. Hey, it's a relational database. They've been around for, I don't even know how much, 50 years? 40? Something like that. Certainly older than me. They also have a very predictable performance model, which means if you have a good growth of users which Revolut as a startup enjoys, and it's a fun problem to have, we can deal with it because we know what to tweak and how to deal with that, because we know the tool. And also to manage complexity of Postgres, we use Flyway, because we want to have migrations in code so that everybody always knows what what shape the database is in, and you can read the migrations, and then you can also test data stores using test containers. And I hope if you're using Docker in a commercial setting, you know about the license changes, but if you don't, then please read about it. I am not going to speak about it at all. But we also use Juke, which means we don't use Hibernate. Why do we use Juke? Because Juke is a very nice DSL for writing SQL queries, which reads almost like SQL. And somebody could say, why don't you use Hibernate? It makes life so much easier. Why don't you use JPA? Because it's a standard. Well, yes, they are. And there is nothing wrong with Hibernate. But we've made a very conscious decision that we want the predictability of the query that is going to be run against the database. Because if there is any doubt, we have the query in text, which we can reason about, and that takes one puzzle out from the puzzle of what could possibly be going, not about how we expect it. Standard means an agreement, but standard doesn't mean that it's what always fits your solution, your problem space. And if there is a standard that doesn't fit, then don't use it. We certainly feel like that about Hibernate. It doesn't mean that you should change, but if you're making a new service, I would encourage you to give Juke a try. So we go on. Legacy will happen. That's a sad realization, and I told you that it's going to be a surprise, so it's impossible to an extent to keep services modern forever. But you will have, over time, with the software that you're building, you will be reading it much more often that you will be writing the software. The question is, who should do what? Domains, areas of responsibility, who is responsible for which code matters. Maintainers, so the people who are responsible for certain applications, certain areas of the code, are the first layer of defense that you have against legacy. Why? Well, because if you build something, you run it. And if you run it, you have to deal with the consequences. That builds a very powerful feedback loop in which you look at any PR that you or your colleague or somebody from a different team might have sent you with the glasses of, hey, is it going to cause me problems later this week or maybe tomorrow? Also for us, it means that if you need to modify the infrastructure which your service runs, just go ahead, modify, change the RAM settings of the containers, their number, and so on and so on. We also have a process around watchmen, so dedicated engineers who on a specific date look through all the anomalies that happen within a service, but they do it only during working hours. And it might be surprising, but engineers look for anomalies, they triage and report bugs. Why do we not have support staff doing this, somebody could say? Well, because engineers are building the software. Engineers will be the one making changes to the system. So they have to understand, they have to build and enhance the mental model that they have of the services that they look after. And bugs and errors in the logs are exactly a signal for this. And so let's have a look at architecture. Upfront warning, the next picture does not come from Revolut. Is this architecture? I hear a no, and I agree with you. Good choice, sir, but I have no gifts. I can take it. An awesome camera, you have that, indeed. Architecture, to me, means a shared understanding of what is of what takes place in the system. It's not about technology, or part of that answer to that is about technology, is about the components, it's about how and what, and so on and so on. So, is this picture enough to be called architecture? Again, the previous answer from the room, no, would be correct. This is an inventory list. It answers the question of what services do we have. It doesn't tell you much more. Let's try differently. Let's put them in domains. That's certainly architecture. Still no, we are going to get more of a service map, which will answer the question of where should a service X or F or E1 or whatever be built, but nothing else. There is nothing about moving, there is nothing about flow, there is nothing more there. Architecture is shared understanding. And to get shared understanding, you also have to be able to reason about the consequences, and you best reason about the consequences that affect you, because you have that mental loop, because our brains are wired this way. I don't know how and why. So, how do we document this? We have a process, of course, called technology design review. Technology design review is something like writing an RFC or writing a design document, whatever we want to call it, mixed with architecture decision log. Architecture decision log or record is a thing described on GitHub. It's a thing well known. Out of curiosity, who here does architecture decision logs in their companies? I see, I would say, roughly 30 hands in the room. If you are going to take away one thing only away from the stock, have a read at this, implement this. This is probably going to be the biggest change to your organizations, but you're going to see effects in a year. Who makes those design reviews? Who writes those design documents? The answer that we use is every engineer. Who reviews them? Engineers. Why? Because we as engineers who own the services, who are responsible with maintenance, who are responsible with growing something and dealing with consequences, have something that's Mr. Taleb calls skin in the game. It's a book that could inspire you, but I think you get the concept. If it affects you directly, you will have a different perspective about something. And then the follow-up question could be a bit more technical. How do you write a design document? How do you describe a service? How do you describe a system? How do you describe the interactions? I will recommend two approaches. Of course, if you remember EJBs, feel free to use proper UML, or you can use rectangles and lines, and that also works. But if you want a very comprehensive model, already defined and described, and something that can be a common ground that you just adopt and use as a tool, effectively, C4 model is absolutely awesome. Have a look at it. That means that you can use an open source, which means free, diagram editor. I recommend PlantUML because I like it. Additionally, because you make PlantUML diagrams by writing text, which you can easily put in GitHub or Bitbucket or wherever, and follow the C4 model. Making architecture diagrams, big shock to some, does not require an enterprise architect license. Why text? Because you store the thing on the left and then generates pictures on the right, which means if you need to change it, it's very easy because you just edit text. When I work with code, I do work with text much more often than I open Photoshop. Another aspect, internal open source. I mentioned maintainers and I mentioned doing PRs. We have an approach in which all of the code of our services is open to engineers working within Revolut. So if I want to read the service that some of my colleagues are working on, I can just clone them or read them on Bitbucket, my choice, and make a pull request, comment, maybe join a discussion about the pull request. Well, anything is open. And there is only one limitation. Service owners, or the people who are the maintainers, are they are the only people that can accept a change in, because you already know why. They have the feedback loop, and they have to polish that feedback loop. So, coming back to the pictures, let's talk about interactions. What kind of interactions can we have between those services? Well, is this going to be a good diagram? I will say maybe, but what we do and what we have found working in the context of having many microservices is first define the interaction patterns, because if you have the interaction patterns defined, and it's most likely going to be an RPC and maybe event-based, maybe a batch, maybe something else, you will know how to solve those problems exactly, because there is not going to be that many of them. And after that, you solve one of them ideally once or maybe twice for the whole company, and then you're richer. So what do? We do something called clients, which is service owners will create and maintain client libraries. Let's say there is a service called Banana. Banana will have a Banana client maintained by the same people and published by the same people who do Banana. And then if you want to integrate with Banana, of course you can use the REST endpoint or whatever other interface there is to the service, but you can also use Banana client. And that encapsulates the interaction patterns already. That means that that banana client is tested. That means that if there is many of you who need to use banana client, you don't have to write banana client each on your own, because that would be quite repetitive, but fun, because we like coding. And we also have our own event transport mechanism. If you want to read more about it or ask us why we did that, the booth will be a perfect place. I'm not going to talk about it. But yeah, my talk said modern Java microservices in the cloud. What about monitoring? What about Kubernetes, cloud native, maybe service meshes, maybe continuous delivery? I promised you surprises. So there is a paper. There are probably more papers that say similar things by Nicholas Carr called IT Doesn't Matter. It proposes a very striking idea that IT in general becomes a commodity. I think it's safe to say that cloud services, deployment of applications, CI/CD, just the mechanics of it, are effectively commodities to us. So it doesn't really matter that we would run Kubernetes and somebody else will run Kubernetes. It gives us exactly no difference. We can run VMs. It makes no difference to the business, most likely. You can also replace Kubernetes with serverless or something else. Maybe Edge is going to be a big opener, but still, it's going to become a way of solving a certain problem, which means solve this and solve this once. Solve it ideally for all the applications, because the big differentiator for your company, the big differentiator for all companies, is about solving business problems, which leads us to the question of how do we efficiently and well capture business reality. Sadly, this is a very, very broad subject, and we as the IT domain have not given a very good answer. But there is one tool, or one set of tools, or one area of tools that I really like. Google Event Storming. Maybe speak to Wojtek Tak, who speaks here tomorrow about that and other connected subjects, because he's really passionate about it and knows a lot. The thing is, software is a people problem, and by it being a protein-limited problem, protein-based solutions do not scale that easily. So the real difference where we as humans can bring is by converting business problems into code, so solving them. And sadly, the technology, as simple as it can be, can get in the way. So the premise is let's try to simplify it, not overcomplicate our lives, and be happier in the long term. TLDR, if somebody had a good map. There is plenty of complexity in most of your businesses. We are optimizing for long term, and if you are also optimizing for long term, be conscious about it. Quality and resilience are long-term investments which pay off probably much better than crypto right now is doing. If you make software simple to understand and scale and change, software will be pleasant to work with. And this is probably what actually the answer of what modern software, you can keep software being modern. If it's pleasant to change because it's still flexible, it's quite nice. So how do you get there, or where to find more inspiration for such ideas? There are books. There are many books. Read any of them, read some of them. They are going to help you, but also talk to your friends about what works and what doesn't work in their specific contexts, and enjoy the rest of the conference. I will say thank you so much for being here with us and with me and listening to my talk. And if you want slides, ags@revolut.com. And now it's time for Q&A. So before I open Slido, or while I open Slido, I'm going to answer the questions that I have anticipated from some of you, because I know that it makes life easier if I actually do that. Oh, I see a question, why don't you simply use Spring Boot? An excellent question, because Spring Boot has a lot of features that we decided we actually do not need, and something like Spark Java means that we can have a nice REST endpoint building toolkit, and together with Juke and Flyway, it's exactly what our services need in 95% of cases. And this is the answer. We avoided the accidental complexity, or we avoided the ability of people to use the extra features so that the software becomes more complex. That's that. If you don't have a tool that you don't want to use in your shed, you're not going to use it because it's not there. As it sounds obvious, but basically that's what we did. Why don't we use a dependency injection framework? Is dependency injection wrong? The answer to that is no, it's not wrong. It's a tool. It solves a problem, and it does solve that problem very well. What we wanted to avoid is the effect in which if you are using a dependency injection framework, you are going to sometimes see people inject things into places in which they should not inject them. We wanted consciousness and increased consciousness and repeated thinking about what gets injected where, because it's visible in the code. And also as a bonus, we used Juice. We wanted to upgrade to Java 9. We couldn't because Juice was lagging behind, and then the same thing happened over, so we eventually migrated to 11, partly because of that, so that's that. Which technologies didn't work out for us? I mentioned Juice, and sadly also Scala. So we don't run a lot of Scala. We have only a limited use of this. Why? Because it is possible to write Scala code that a person who just joined the company who doesn't have a lot of experience with Scala cannot really deal with. So there is nothing wrong with the language. As in, I personally love the language, but it doesn't sometimes pass the 2AM test. What about Lombok? Well, we've discussed it, but I'll add this while I look at Slido. Why don't you like MongoDB? What is wrong with that? There is nothing wrong with MongoDB. It's a tool. It solves specific problems. MongoDB I find particularly useful if I'm in an experimental phase of a project and I don't know what I want to store where. But if I'm optimizing and building a piece of software that I know what kind of life cycle the data set should have, then I'm probably going to be happier in the context I operate in. As in, right now I work in a financial services company. So in that context, a relational database is just a much better fit. And other Mongo stories will have to be told outside. What about serverless? If it works for you, just use it. That's all I'm going to say, because it's like Kubernetes. It's in infrastructure, and it's a solution that is perfectly fine. Are you doing DDD? If yes, just using Spark Java? This is difficult, because we have a lot of teams, and different teams in different areas do different amounts of DDD, and it's not even constant over time. I can certainly say, I wish we did more DDD, and I wish we had done more DDD in the past. But Spark Java and DDD are kind of like orthogonal problems. You can do DDD without using any web framework at all, and you can do DDD with using Spark Java, since Spark Java is just a vehicle to expose REST endpoints for us. So the important part of DDD, the important to me, happens on a higher conceptual level. What's your approach to maintenance of services which work for years and do not require any changes? Do you upgrade libraries, versions, JDK to the latest? Yes and yes. We are upgrading client libraries to the latest always every time we deploy. And built-in libraries, we try to stay rather fresh, because this is a company that's dynamically growing, and we have a lot of engineers, and engineers like keeping things up to date. So we are trying not to stay behind too much, because it will end up a burden when you finally want to upgrade. We're not perfect on that stage, but we're definitely quite not bad. Obviously, this is very hard to decipher, because I don't have a report that tells you, hey, we have those many dependencies and those many versions, and this is how much behind we are. But we're trying to stay on the closer towards the up-to-date state rather than behind. What kind of test do you have? Is Spock a silver bullet? An excellent question. We have a couple kinds of tests. Unit tests using JUnit or cotest for obvious reasons. We have then functional tests, so tests that will spin up the instance of a service and will execute its API. And that's usually done using Spock. But now what we see in the company is an increasing adoption of JUnit and cotest to drive those. And yes, you heard that right. We're using JUnit or cotest compiled statically typed tests instead of Spock, and actually reducing the amount of Spock we have, because one application that's sizable has a big number, and I'm talking roughly, let's say, 30, 40K of Spock functional tests, which makes refactoring very difficult. Even with the powers of IntelliJ, we sometimes get those refactorings wrong, which means you only learn about it when the tests are being executed, because Spock, being based on Groovy, being a dynamic language, even if you run compile Groovy, it doesn't tell you all the things wrong, which are wrong immediately. And that's just a painfully long development cycle if you have to refactor tens of thousands of tests. Yes, I agree, we shouldn't have gotten to this big amount of tests in a single service place in the first place, but given we are there, the learning is twofold. One is don't get into such a place, but the second one, there is power in static typing, and it's a tool that we find very useful because we want those services living for a long time. And I think I'm done. We're out of questions, we're out of slides. Thank you very much. Sorry, this is for tomorrow. Enjoy the rest of the conference.